Welcome to May. We are going to start out the month of May with one of my most favorite things that we do in Algebra 2, which is learning how to divide polynomials. And we're going to approach it from looking at it like it's a puzzle. So to start this out, we have to kind of think about what we've done in the past. We've looked at a variety of different ways to express polynomials. We've talked about factored form. We've talked about standard form. We know that factored form makes it easy to find the x-intercepts or the roots of a graph. So Andre is in a situation where he has to find the roots of a function. But he looks at it on his graphing calculator because he figures he'll use his graphing calculator. And he sees that he knows for sure that one of the roots is 2. But he knows there's 2 others that he cannot identify exactly from the graph. So he remembers back to the area model that we use to multiply and to factor, and he thinks that he can use that to help maybe undo the multiplication that happened in order to get that standard form. So what we have here is this new puzzle called a polydoku, and it's a game. So in short, we'll read it here. It says, math enthusiasts around the nation have entered a new puzzle craze involving the multiplication of polynomials. The goal of the game is to fill in squares so that the multiplication of 2 polynomials will be completed. The game at the right is a completed game, represents the multiplication of 3x minus 2 times 2x cubed minus x squared plus 3x minus 1, and the product equals this. But what we see is that this is the completed game. So to start the game, a lot of the squares will be missing. Some beginner levels have the factors in the gray squares. Some of the factors are missing in the more advanced levels. But most of the white squares are going to be blank. And what I want you to notice about how this is set up is that if we look at any of the diagonals in white, in the white part of the box here, 6x to the 4th is kind of all by itself. And we see that that's equal to the bottom part of the box there. And then the x cubed terms add up to what we see on the outside of the box. The x squared terms add up to what we see on the outside of the box. The x terms also add up. And then we have that lonely little constant term that adds up to itself. So this is the process that we're going to use, okay? So he comes across this polydoku puzzle and he wants to fill in some of the squares. Take a moment, pause the video, and see if you can answer parts A and B. Come back, check your answers, and then we'll look at how we could maybe work through this puzzle. So hopefully those were pretty easy to figure out. You know, we just multiply just like we would if we were multiplying out polynomials together. So now let's work on completing this polydoku puzzle. Now this is a pretty basic one. You've done stuff like this in the past, so I don't think you're going to have a hard time right now. So go ahead and fill it in and make sure you write out what that bottom part outside of the box would be, the final answer, so to speak. Okay, pause the video, come back when you're done, and check your answer. All right, so hopefully what you've got is something that looks like this. Now, you'll notice I color-coded things to make it easier to see kind of what went with what, but it's one of those times when that x cubed terms becomes a 0. So you don't have to write this. You could have just written 8x to the 4th minus 22x squared minus 4x plus 15, and that would also be fine. Okay, so moving on to the next page. Now you're going to see an example of a polydoku puzzle where some of the gray boxes are missing. We have, some of what's going to result at the end, the final product. We're missing a few spots in the in one of the factors, and we're missing a few of the white spots. So this is a higher level type problem that you would, more challenging problem. But let's talk about, how we could work through this. And if you think you can do this on your own, you can pause the video, try it, and come back and check and see how I worked through it as well. Okay, so if you're going to stick with me, let's go ahead and do this. Once again, I'm going to try to color code things here. So what I know is that my product here was 2x to the 4th. And I know that that comes from multiplying this box by this box. So what I have to ask myself is, what do I multiply x by to get 2x to the 4th? And that answer is going to be what goes in that box. So when you think about it, what times x gives you 2x to the fourth. Well, that's got to be 2x cubed. Well, now I know what goes in that box, which can help because that'll allow me to then fill in this next box by taking 2x cubed times negative 4 to get this box, which then becomes negative 8x cubed. Awesome. Okay, so we move on to the next column here. And once again, I have part of that column given to me, but I don't have what goes in the gray box. I don't have that factor. So I asked myself, what would have happened to get me to this 12x squared? Well, I would have had to have multiplied negative 4 by something to get 12x squared. So I think about what times negative 4 gives me 12x squared, and that's going to help me fill in that box. So we know that that box will be negative 3x squared, right? Because a negative times a negative gives me positive, 3 times 4 is 12, and x squared times itself, or times 1 is x squared. All right, so now I know that, I can fill in that other missing part of that column because now I just have to take x times negative 3x squared, and I'll get my box that's missing in that column. So that's negative 3x cubed. Okay, so I'm just going to color this with a different color just so that we can see later where it goes. That's my 12x squared. It's a new color. So now I move on to the next column. And what I know in this column is that I have that header, which is nice because then I know what to multiply by. So that's just like what we did in the previous problem. So I'm going to go ahead and multiply negative 2x times x, and that gives me negative 2x squared. And then I'll multiply negative 2x times negative 4, and that's going to give me positive 8x. Now here comes a part of the problem that might be a little weird because you look and we don't have anything in this column, and you think, well, I don't know what to do. I'm stuck. But what you might have forgotten is that they gave you this here. They gave you this little part underneath the box, which tells you that these two boxes, remember we talked about that diagonal adding up to give you what the product actually is in the end. Those two boxes have to add up to that 12x. Well, that makes us kind of have no choice about what goes here because there's only one thing we can add to 8x to get 12x, and that's 4x. So now I've got at least one part of that column. So I can fill in the rest of the column by kind of doing what we did here at the beginning. You know that you had to multiply something by x to get 4x. So that kind of gives you no real choice as to what that number is going to be. It has to be 4 at the top. And then since you have 4, you can go ahead and fill in the rest of that column by taking 4 and multiplying it by negative 4 and getting then negative 16. So now you have all of the pieces. Now it's just a matter of adding them all together to write your final product. So we talked about how everything happens on the diagonal. Well, this corner doesn't have a diagonal to work with, so we start out with 2x to the fourth. But then this has a diagonal. Those two are like terms, so we add them together. We get a negative 11x cubed. And then we move on to the next diagonal, and we're going to get plus 10x squared. And then you have that plus 12x that was given to you, minus 16. So we were able to fill in all of the parts to that puzzle without knowing everything. We had to reason through pieces of it. Okay, we're going to try another one here. Okay, so if you think you're up to the challenge, you can go ahead and try this one. And you'll notice the big difference here is that we are given no part of the top factor and nothing inside the box. The only thing that we're given is the final product, which I've color-coded, and one of the factors. So if you think you can do it, go ahead and pause the video and come back and see how you did. If you're going to stick with me, we're going to go ahead and start right now. Before I begin, I want to highlight the boxes that correspond to each term. So like this is going to correspond to our 6x cubed. These two boxes, because they're on the diagonal, are going to correspond to the 7x squared. These two, because they're on a diagonal, are going to add up to be negative 16x. And then this last one, since it's by itself, will be our constant term of 10. Okay, if you think you can do it, go ahead and try now and then come back. If you're going to stick around, let's go ahead and talk about this. So here's what I know. Because there's only one cubic term, I know that that term has to be 6x cubed. knowing that puts me in a position right away where I can find what needs to be up in the top part of my factor. So I can right away start to think about what this would be. Okay, so I have to think about, well, what do I multiply 2x by to get 6x cubed? And I think most of you would probably be able to figure out, well, that's just going to be 3x squared. All right, perfect. Well, now that we have 3x squared, I actually can fill in the rest of this column. So I can multiply 3x squared times 15x, and that's going to give me the other missing piece of that column, which will be 15x squared. Now that's great, but we're kind of stuck again, right? And this is similar to the last problem where you had to think about what the end product was and what you have and how to get it to that end product. So here's what I know. Right now I have 15x squareds, but I need to end up with 7x squareds. So I need to take away 8x squared. So that's what has to be in this box then. Okay, there's no choice. It has to be because now they add up to that 7x squared. And now we can think about how we got the 3x squared a minute ago and just continue this pattern. So I know that we have to get negative 8x squared, and it comes from multiplying 2x by something. So again, you should be able to figure out that's going to be negative 4x. Once you have that negative 4x, well, now we can figure out what goes in this green box here, because negative 4x times 5 is what's going to go there. So then we're going to get negative 20x. And then again, the beautiful thing is we have the final product here. So we know that something in negative 20x have to combine to be negative 16x. So we can realize, okay, well, we have to add 4x to negative 20x to get negative 16x. And then at that point, we can go ahead and figure out what goes here by taking 2x times something to get 4x, which is going to give us 2. And then at that point, it's a very easy thing to finish filling this in because we just multiply 2 times 5 to get 10. And there, we've completed the puzzle. What we're really doing here, guys, and this is what the statement below is going to be talking about, what we're really doing here is dividing polynomials. So we're taking this polynomial, which we wrote here, and we're dividing it by 2x plus 5. So when we do that, we get the factor you see up above, 3x squared minus 4x plus 2. So this is equal to this. And another way of writing that, and that's what they're doing here, there's really two different statements happening. Another way to write that is a way that we're used to seeing, which is to take 2x plus 5 and multiply it by this to get that product. So we have both the multiplication and the division that we can write in from this Sudoku process. So this is dividing polynomials, and this is a really important skill when we start looking at finding the intercepts of a function. Okay, so just to kind of wrap this part up, Jessica realized that she had written the problem incorrectly. Okay, so what she noticed was the constant term of the original polynomial was supposed to have a value of 18. So let's go up here and change this to 18. All right, so instead of 10, we're going to have 18. But this won't change, right? We're still going to have that value there just like we did before. That's still 10. But what's interesting is that, we have this leftover from what is still here. In other words, if we were to extend this box, so let's just draw in another box here, okay? So let me see if I can do this for you guys. And think of this as the other part to the constant, right? So what we would need to do in order to get 18 would be to add something to 10, and we would add 8 to 10. Well, that 8, because we can't go any further, there's no other terms left in our polynomial, that 8 is actually what we would call our remainder. Okay, now, if you look down below here, she wrote her work and used this same process from up here. She rewrote it, but she has this remainder of 8. Now, to do that, without writing the word remainder, what we can do is we can say, okay, I'm not going to rewrite the fraction again, but what it's equal to is 3x squared minus 4x plus 2. And then we'll say plus 8 over 2x plus 5. That's one way that we can write our remainder. There's a lot of other ways, and truthfully, we won't be doing a lot with the remainders this year, so that won't be a huge part of the process. All right, so let's go through one of these together from scratch, and then what you'll see in your form is actually the 4 problems below. All right, so let's talk about how we can do this. And the first thing we've got to do is set up our box. So you'll notice I set it up just like we did in the previous problems with the shaded areas as well. You don't have to necessarily have those shaded areas. I mean, you can just, set this part of your box up and go from there. If you choose to do this, you don't have to shade it either. Just know that those outside rows and column are your shaded areas. Now, the second thing we're going to do is figure out what goes here. Well, that's going to come from what we're dividing by. So this 3x plus 1, that's what's going to go along the outside of our box on the column. Now, this piece is what goes on the bottom of our box. And I like to color code things just to keep it a little bit easier to organize, but that is going to be completely up to you. Now, I knew that I was going to need to have a total of 4 columns and 3 rows. And I know that because this is 2 parts, there needs to be 3 rows. And because this is 4 parts, we're going to have 4 columns. It's a pretty easy way to understand it. Now, one thing to watch for is you need to make sure that all of your powers of x are represented. If this were something like 6x cubed plus 11x squared minus 1, we would have to rewrite that as 6x cubed plus 11x squared minus 0x minus 1. And then we'd have to put that 0x where you see the negative 12x here. Okay, and you can write it as plus 0x too. That doesn't matter. Either one's fine. But just watch for that, and that's the first thing that you want to check on when you're writing this in your box. Okay, so now we've got it ready to go. We've got the box all set up. Now it's just doing what we did in the previous problems. So we ask ourselves, how do we get started? Well, here's what we know. And again, if you want to shade things to make it easier to figure out where pieces are going to go, remember that the parts that are on the diagonal will be the parts that get added together. So I can shade things to kind of set that up so I know what's going to go where. Now it's ready to go. I can just start putting things where they belong. Since there's only that one pink cell, I know that this has to be 6x cubed. It doesn't get added with anything else, therefore it has to be 6x cubed. Now that allows me to figure out that top part of that column. I know that 2x times 6x cubed times 3x will give me 6x cubed, so I know that has to be 2x. And then what's really nice, 2x squared. What's really nice about that, as soon as you get that top part of the column, the rest of this falls right into place. So I'm going to go ahead and multiply 2x squared times 1, and that's just going to give me 2x squared. And then remember, and I did this with the shading, because these are both purple, these two are going to combine to give me that 11x squared. So I know that I've got to add in another 9x squared in order to get 11x squared. And then I have to ask myself, okay, well, what do I multiply 3x by to get 9x squared? Well, I know that has to be 3x. And then again, once you have that top column, the rest of it sort of falls in place. So 3x times 1 is just going to give me 3x. And then I ask myself, what do I add to 3x to get negative 12x? And that's an interesting one. And that actually ends up being negative 15x. Okay. And then I ask myself, all right, what times 3x gives me negative 15x? And that would be negative 5x. I'm sorry, negative 5. Whoops. Wrong color. And then negative 5 times 1 is just negative 5, and that's going to be my constant term. Now, what's interesting is that it doesn't work out perfectly, right? We would have a remainder. So I'm going to set up a little remainder box here that you can choose to set up if you like. You don't have to. And you can set it up with every problem you do, or you can just set it up once you start out the problem and realize that there's going to be a remainder. I know that this is going to be my remainder box, and what I know is that this is the part that's on the diagonal for the constant term. So what I'm figuring out is what would I have to add to -5 to get -1, and I know that's +4. So my remainder is 4. So my answer to this problem, remember, we're figuring out what the division of this polynomial is, these two polynomials are. My answer is what's here, with any remainders that might be necessary. So my answer is going to be 2x squared plus 3x minus 5, and I have a remainder of 4. So remember, we talked about the remainder will be written as whatever it is over what you're dividing by. So that's my answer. Like I said, in a moment, you're going to be doing the form, and you're just going to do those 4 problems that are below. Okay, good job, guys.